Mario, once again with my microflight. In my previous video, I talked about making an adapter ring so that I can maintain the same wheel, a modified wheel. This is a 4.1 slash 3.5 dash 4 for 4-inch rims. And so I modified this wheel on on my first video regarding this project here. I cut out this section here to make this a 5-inch inside diameter opening so that it would fit over this brushless hoverboard motor. As you can see, that fits quite nice and snug there. But the problem is that you can see how much of a gap there is here if this does not have enough flange on the outside to hold the tire, and that's, I believe, what happened when I was test riding it on my go-kart, the racing go-kart. It has great travel distance. I really like the way this was working. You know, with this larger tire, you're able to gain a little more distance with this versus just the hoverboard motor solid tire, which is, I believe, it's the diameter of that is I would say about 5, 6, maybe 6.5 inches. There's about maybe an inch and a half of tire material here, right, on the original one, the hard tire. With this is a lot better, and it's also pneumatic, so it's able to absorb a lot of the bumps, and it makes for a really attractive setup here. So I didn't, you know, I refuse to give up when things like this happen, and I have to find a solution. As I was saying in my previous video, this is what happened. It exploded. If you want to hear more about the details, how what my thoughts are on this, go back to the previous video that I did on this, where it says solution ? Because I did that video as a primer to this video right here, which I'm going to be talking about some possible solutions here to this. Now, in my drawing, I showed the basically the front view of the wheel, and then the side view where you see this part right here, like that. And then my solution was to have some plates here, some of the 5-inch inside diameter plates, to make up for the lack of additional flange here, so it'll grab the wheel with this. So it'll grab this modified wheel, I should say, because once we lose that rigid inner ring by cutting this, this can really pop out of the this really shallow flange that this has here. So we need to increase that width so it'll grab more tire area on the outside, on the inside of this diameter here, and it'll really retain the wheel so it doesn't pop out, in operation. So that was my my thought in regards to a possible solution, rings. So I went online once again, as I typically do. Try to find rings that would fit something like this. I was thinking of maybe a steel. My original thought was a steel ring. If I can find a steel ring that would fit this. I searched online, then I went to Home Depot, and they do have actually a flange that will fit here that has an 5-inch diameter. It's used for toilets, to make toilet connections, to the seat. But it's got some other geometries and openings, and it was too distracting when I popped it on the wheel. It was like, yeah, that would work. I think they were like, on top of that, they were like $6. I don't want to pay $6, for it, because it defeats the purpose. $6 times 2, it's additional $12 that I need to invest on this. And my original thought was not to work with this wheel, and not to purchase the one that would typically work with this. As I've seen on some other videos by some other people that went and got the 5-inch, the 5-inch tires for a 5-inch rim. This is a 4-inch rim, and that's why I had to modify it, because I didn't have the 5-inch, and I don't want to wait to get the 5-inch, and I don't want to spend the money also, because those are like $21 per set, tube and tire, and that's it. So times two for the go-kart, the rear wheels, that's a good $40-50, with shipping and taxes and all that. So I don't want to do that. And I had these wheels, and I actually ended up buying 4 more of these at $7 a piece, complete with the hubs from Harbor Freight. And so that's what I want to work with. I really want to make this project work with these wheels right here, so that in case anybody wants to do the same thing, they have the solution, they have the means, they have the know-how, and they can do this. Cutting the inside diameter is not it's not as quick, but it's not really hard if you take your time. You can cut pretty decent diameters. You see here, it's got a little bit of imperfections here in the circular geometry here from my hand cutting it and just cutting it by hand, but you can still do it. And as long as you get this right and you come back and you clean up these edges here, I think this would work. I should also mention that maybe when I mentioned in my video on the modification of this tire, I said, you need to cut below this ring right here, this most outer ring on the inside of the tire, one ring below that. Perhaps if I would have cut another ring below this one here, there's another line. Maybe this would have retained itself better in here, because as you get closer to the original inside diameter, the material starts getting thicker and thicker, and so it's able to retain its inside diameter more static than this. This is a little floppy, as you can see here. Not really floppy, but because this has got a good 3/16 inch thickness here, at least 1/8 to 3/16. I think it's 3/16. And so perhaps if I would have done that a little closer, it would have made it really difficult, to insert it over this 5-inch rim, because now you're talking about an inside diameter of a tire that's, it's rubber. It's really thick rubber. It's not like a rubber band that expands. It flexes, yeah, but it's really difficult, when you start to insert another item like this hub, and so it would have made it a little difficult, but perhaps it would have retained better on the wheel. So that's the other thought. I mean, I have to cover all these bases here in case there are questions, there are other thoughts, there are people thinking along the same lines, and maybe thinking, well, why didn't this guy cut this inside a little bit closer? I could have done that, but this is what I did. So now I have to find a solution. So the plates is the solution here. I am absolutely sure that these plates are going to provide the solution. So in looking for plates, I'm going to Ace Hardware Store. I looked at Walmart. I went to Home Depot. I went to the I even thought of, I was going to say something, but I'm going to reserve that for in a little while here. I even thought of, last night I was thinking, I should just 3D print or machine, CNC machine my own rings. There are some companies that produce custom what they call goof rings, and they're designed to cover holes that on the ceiling that you may have cut too big for those recessed lights, and then they have these what they call goof rings, which have an inside diameter and an outside diameter. It's just a ring, a plate. And you can select your whatever inside diameter, whatever outside diameter, and then they make it for you. For about anywhere from $6 and up to $12. You can have a plate. Now we're introducing another $6 per plate. Like I said, I mean, it's not any better than that adapter for the toilets, that ring that has the exact 5-inch diameter. You can get at Home Depot, and those are pretty thick. They're steel. So I don't want to spend $6. At the most, $1 per plate is my target here. $1. If I can make these things out from for $1, great. So I can 3D print real easy, the ring out of 1/8 inch, just go with 100% infill PLA or even ABS. ABS would work better here than PLA, because PLA tends to soften up, with heat a lot quicker than ABS. ABS, it tends to retain its it gets hot, but it doesn't go limp, like ABS. So, and because this is a mechanical assembly that needs to be nice and solid and firm and secure, ABS would work a lot better. And so that's one option, the 3D print, or I can CNC cut. I do have some 1/8 inch fiberglass sheets that I can cut rings from there, so that's another option. Uh, but then then I have to set up my machines. I have to design the part, and so I've been trying to avoid that and see if I can really, really make this work. And also thinking of people that don't have a CNC, don't have a 3D printer, how can they do this? And so I've been thinking of using stuff like this, plastic. These are hard plastic. I think these are some kind of a polypropylene. Polypropylene is super, super durable, and it's not gonna melt or anything, in the sun. So this stuff is super, super tough. It's the same stuff that milk jugs are made of, polypropylene, polyethylene stuff. So I found these at the dollar store for about $1.25. Now it's $1.25, no longer $1. They went up in price, but it's still, 3 for $1.25. That's more like it. I also found these doggy trays, and I've had this from before. I just, when I started thinking, not finding this, I go, I have something that might work here. So I went back and I got my trays. I bought these so that I can mold over them, so I can do wheels, foam wheels. Heat this up and make this the form of or the mold of the wheel. So I did this for that project, but it didn't materialize because I went on to doing other things. So I got those. I got this also as just to make molds out of this, to pour material here, and this just to form over it with heat. So I got these, and I got I got 3 sizes, because when I buy these things, I not just buy one. I buy, like, if they have 3 sizes, I'll buy the 3 sizes, especially if I'm going to experiment with. Because sometimes if that one doesn't work, the other one will. The more the variations you have, the better you are. When you, and for $1.25. $1.25 for 3, $1.25, $1.25, $1.25. That's really, really cheap, the dollar store stuff. So I found that the second size of this guy right here works beautifully inside this wheel right here. Look at that, and it looks awesome too. If we were just to just use that as a half a hub plate. Can we insert this inside here? Absolutely, you can. Look at that. Okay. So that's one option here, and it's got this really nice lip here, or flange, and it's not sharp. It's very smooth. I don't know if this is stainless steel. Let me see what material this is, because being that from the dollar store. It doesn't say what material this is, but this feels like really thin material, and I believe this is thin because when they form these things, they form these over a steel mold or a plug. And the way they start this is with a flat sheet, and then they form it. They force it into this cavity here, little by little. If you've seen videos online, on YouTube, how they make pots and pans, stuff like that. That's how they do this. It's almost like they're forcing the material and stretching the steel over the form. And that's how these things are. I believe that's how this is done. This way, this part right here is the thinnest part, because by the time the material reaches this part, this has stretched. So, but it's working real nice. I won't be using this, so I would have to cut this right here at the 5-inch diameter, and this would fit over that. Except that my 5 inch cut would end up about right here with about a quarter or about 3/8 inch from the edge here, from the very edge here downward, and I would have to flatten that out, so that it doesn't stick out on the inside of this flange here. So that is one option that I have here. I just need to go buy 3 more of these, and then my problem is solved, provided I also cut this. Now, it's one option, going with steel. The other option is going with this polypropylene, which is, this is actually a little bit bigger than this guy here, which is even better. Just by maybe another 1/16 of an inch extra rim. And this would also work the same way, because this also fits in there, provided I come back and cut this. So how can I cut this is my other challenge. Okay, I found the items that I can use, as my flanges. Now, in order to cut this, I remember doing, when I used to mold my flying saucer canopies, for the Blade MQX. For those of you who remember, the one of the first quadcopters came out to the market from E-Flight was the Blade MQX, and so I was making all kinds of cool parts for that. I was making canopies, and I remember molding these canopies, all sorts of canopies. And after molding, I needed to come back and trim them exactly, flat, and so that they would end up parallel, with the top surface. And so what I ended up doing is I ended up making a plug. Imagine this would be the that canopy. I made a plug on a ball bearing type turnstile, where I can rotate this with very minimal effort, and it would be very precise. And I put this on top of my my drill press, and I had the drill press with a cutter, with a blade, about maybe a 2-inch blade saw. And then I would come in and just rotate this around, and I would end up with a perfectly cut